is Europe, which just is kind of tying back into the Arctic bipolar video, kind of like a follow-up
Mm,
um, into what that graphic showed. We talked about that versus what the data said about the winter season in Europe was their hottest winter on record in human history. And I had to shout out to you, obviously, because this was you were ahead of the game, Jim. You got to this before the papers released the shocking data. So it's the Guardian again.
I'm still in the trenches, still privy to the data before it gets out there. So
It's really just that it's the same graphic really of what we talked about with the Arctic bipolar, but now they're linking it to the hottest winter on record for Europe. And
and when you look at that graphic, okay, it's showing more the Mercator projection, I guess. But you can see pretty much the Eurasia is just like cooking. I mean, it's really hot in Eurasia, especially in like Siberia. I mean, Siberia is just really above average, like 1.6 Celsius above average. And then you see that blue band right across Alaska and into
yeah,
the Canadian archipelago, Baffin Island, Ellesmere into Greenland. You get that little cold band there, but the rest of the planet is at least near or above average, and Siberia is really very, very warm. And if you look at that right-hand panel, you
right.
see Greenland is in blue. That's if they were to extend that further, you know, to the you know towards the Alaska side, we would be recreating that bipolar graph we showed last week.
I see. Um, it's just very eye-catching is one way to put it. Well, I wanted to get into the
It's
details because I really like how you explained last time about the 30-year average and the importance of looking at that data because now I can understand the graph better because they're using 1981 to 2010, um, that 30-year average, and they're comparing Europe's winter to that average, and it's 3.9 degrees Celsius hotter than that 30-year average. And you explained last time, if you want to do it again, like the how that's really telling that things are warming up.
well, just for 3.9 degrees C, that's roughly 7 degrees Fahrenheit.
Okay.
So that's for every degree C, it's 1.8 degrees Fahrenheit approximately. So yeah, so you have, and by the way, I realized I misspoke last week when I said that, I converted 8 degrees C and I said something like 12.4. It was actually 14.4.
Okay.
I,
Hey, it
I
happens.
carried the wrong number over.
It's okay, Jim.
No, that'll teach me to try and do math in my head.
Fine. It's fine, Jim. Honestly, it's I mistook what northern hemisphere for being in summer, so I was messed up. It's fine. We're
But what
correcting
was
it now.
but what we're seeing here is really the the AO being and along with the Arctic dipole really being strongly entrenched over the Arctic, and so that you get extremely warm conditions in Eurasia with near cooking conditions in Siberia, and then you get the cool side on the North America side of things, Alaska through the northern Canadian territories, etc., Nunavut, Yukon,
Wow.
into the archipelago, Ellesmere Island, Baffin Island, and finally into Greenland. So that again is just showing the Arctic oscillation and the Arctic dipole. And I can tell you pretty much right now that most of the sea ice is being contained within the Arctic Ocean basin. Not much is going out the Fram Strait.
Okay. The man on that Eurasia side, like night and day.
It is.
And we've talked about this before, but what does that do to the permafrost, and the rate of which it's thawing is something to think about.
Excellent point. When you got Siberia like that, and Siberia, I mean, Siberia is where a great majority of the permafrost is found. And I've mentioned before, Igor Smelatov and his wife Natalia, they're kind of the ones leading the charge, so to speak, on trying to ascertain just how much carbon is locked up in the permafrost. Not just across the circumpolar north, but in Siberia, in Russia. And so they're trying to, this is one of the things the climate scientists are trying to ascertain, is exactly how much carbon is sequestered. It's being released. So we want to know how much is there that could potentially be released into the atmosphere, but more importantly, at what rate will it be released at? Is it going to be like meted out slowly and steadily, or and this has happened before in the past, will the Earth have a burping or farting event, depending on your perspective, where a large amount is suddenly released?
Mm-hmm.
The methane question is what concerns climatologists when you really get down to it. And it is a tremendous amount of methane, carbon, whatever, locked away in Eurasia, in Siberia. That starts getting released and released all at once or very quickly. It's going to have extremely telling effects.
And you could argue that is most likely, very likely scenario. It just depends, but I know
it will lead to further thawing. It will lead to, further warming. You just create this massive positive feedback loop. And I've done videos on this where a lot of communities in the Arctic, they depend on the ground staying frozen.
right.
You build roads on top of the ground staying frozen. You don't dig a basement. You don't pour a foundation for a house. You build up on the land. Well, if the land starts thawing out, house is going to be sinking and crumbling. The roads are going to be sagging, and you get lots of frost heaves and dippings and all sorts of whoop-de-doos, as I call them. but, but, I mean, it's going to have adverse economic impacts, and I've done some videos on that discussing, the potential economic impacts on northern communities as literally the ground around them thaws out and collapses.
Right, you said about $70 trillion are at
Yeah,
stake by 2050, right? There was a difference by like 2020, 2100. It was like, oh god, the number you gave out was like 2,197 trillion.
it's a bit.
Yeah, so the economic impact is tremendous.
is
I hate that word at this point, but like,
And the thing is, that's the only thing that's going to get politicians to act. You give them the science, they don't give a shit.
mm-hmm.
When you start talking about economic impacts, we'll talk more about this later when we talk about Corona, but you get the economic impacts. This is going to be very devastating.
Right.
Uh, I mean, for example, in Alaska, they've had to relocate whole villages because the ground is, there's no sea ice to protect the coastline. So you got the storm in the waves battering the crap out of the coast. The ground is thawing, and so you got whole chunks of real estate just dropping into the ocean. And they literally had to pick up whole villages and move them because they stayed put. There wasn't going to be a village. It was going to be in the ocean.
Right, we're losing land
And
as we
losing
speak.
land.
Yeah.
Yeah. So you're losing land to, chunks of land because the permafrost thawing and chunks of land dropping in the ocean. You're losing land to rising sea levels. Couple that with 7.8 billion people. Where are you going to put them?
I don't know. It's not in high rises because those are too expensive. So
Yeah.
yeah, there's so much
Everyone will soon
fear.
be living in these little, uh, 4 meter by 5 meter things where you pull the straw out there. There's your couch. You pull this other thing out here. There's your bed. I mean, it'll be all this like modular furnishings.
I
Be
know.
just be crammed in like like I don't know, rats, whatever.
Yeah, that is a dystopian future.
Yeah, it's not very pleasant.
No, we're going to be competing for space and resources if
Hmm.
this continues. I mean, that's a whole nother topic.
Yeah.
It's apocalyptic shit. God, you know.
And we're also losing land just because of becoming uninhabitable, either too hot, too dry, too wet, what have you. I mean, for example, the Middle East is projected to be uninhabitable by 2040, 2050, if temperatures keep going as they are.
That's 20 years, okay?
Yeah.
20 years. And it's not just, right, it's going to start now, but it's going to progressively get worse to that point. So,
I mean, when they start talking about temperatures, sustained in the upper 130s, good grief.
yeah, like 133 degrees Fahrenheit, I've heard. Like,
Yeah. 133 to 141 is like, good God.
you're done.
I
You
mean, it's
can't.
just like fry your brains too.
Is that even recorded anywhere on this earth at this point, like naturally? Like, I don't want to say, I don't even know how to frame that right, but like,
I think Death Valley.
okay, it can get up to those temperatures like 140.
No, but I think, hang on.
No,
Uh,
sorry. This
I think they, I think it was 131.
okay.
Let me check. Oh,
No,
wait a
130.
second.
I mean, 110 plus is we're in trouble. Okay, anything above 130 as a human being.
Oh, great place, a great name for the place, 130. Furnace Creek.
Seriously, they have no humor. It's just like this is what this,
Furnace Creek. That's pretty funny.
which means there is no creek or the creek. I don't even know. I don't know what kind of lack.
Okay, so let me see. Then Death Valley smashes heat record, second year in a row. So for the second year in a row, July in California's Death Valley record the award for the hottest month ever. The finding was reported in Forbes magazine on Tuesday, July 31st, in an article by, wait for it, Brian Brettschneider. He's the guy I share a lot of the tweets with. He and Rick Tolman.
Okay.
He's a climate scientist at the University of Alaska Fairbanks. He's now in Anchorage. The basically, yeah, it was just continuously hot temperatures above like over a 90, over 100 degrees for like days on end. But yeah, so Death Valley, one place.
Right, which is why it's named Death Valley. You will
Yeah,
die if you stay
exactly,
too long.
exactly.
There is like this naming joke with these places, like Death Valley, Furnace Creek. Okay, I wonder
Right.
what's going on there.